Welcome to Algebra 1. Learning goal for this episode is to learn how to solve a quadratic equation using the quadratic formula. For a quadratic equation in the form ax squared plus bx plus c equals 0, the solutions are given by the quadratic formula. X equals the opposite of b plus or minus the square root of the quantity b squared minus 4ac all over 2a. As long as a is not equal to 0 and b squared minus 4ac is greater than or equal to 0. So let's look at this example. Let's solve x squared minus 2x minus 3 equals 0 by using the quadratic formula. First, we identify that a equals 1, b equals negative 2, and c equals negative 3. So now I'm going to substitute those values into the quadratic formula. So I substitute 1 in for a, negative 2 in for b, and negative 3 in for c. Now I start simplifying. We need to remember our order of operations as we simplify. So underneath the radical becomes 4, which is the negative 2 squared, plus 12, which is the result of multiplying negative 4 times 1 times negative 3. In the denominator, I simply get 2 because 2 times 1 is 2. Now I combine the 4 and the 12 to get 16 underneath the radical. I then take the square root of 16, which gives me 4, so I have 2 plus or minus 4 on the top, because the square root of 16 could be 4, or it could be negative 4. That's why we have the plus or minus. So now I split this into my two possible solutions, one where I use positive 4 for the square root of 16, and one where I use negative 4. I then simplify each of those separately, so I get 6 over 2, or negative 2 over 2. When I divide that out, I get positive 3 or negative 1. Those are my two solutions to the original quadratic equation. I can always check those solutions by filling them back into the original equation and seeing if they work. They both do, so I know I've done it right. Let's look at another example. X squared minus 2x plus 3 equals 0. Again, we're going to identify a, b, and c, and we're going to use the quadratic formula. So we substitute in our values of a, b, and c everywhere they appear. We're going to simplify under the radical and our denominator. Then we're going to simplify under the radical one more time. But now we notice that we have to take the square root of a negative number. Since any real number squares will be positive, we can't do that. So we say we have no solutions. But to be perfectly accurate, we should say we have no real number solutions. In future math courses, you will learn about imaginary numbers that do allow you to take the square root of a negative number. For now, though, we'll restrict ourselves to real number solutions. So anytime we end up with a negative number under the radical, we'll say we have no solution. Here's one more example. Negative x squared plus x plus 14 equals 0. So here's our a, b, and c. Notice that a is negative 1 and b is 1. Even though we usually don't write those coefficients in front of the variables, there's still a 1 there. We substitute those into the quadratic formula. We simplify underneath the radical and in the denominator. And then we simplify one more time underneath the radical. Now we notice that we have 57 under the radical, which is not a perfect square. So we can split our two answers out like this. And it's perfectly fine to leave our answers like this. If we want, though, we can use our calculators to get an estimate for the square root of 57. And then we simplify further to get approximate answers. Please note that because we rounded the square root of 57 to 7.5, these are not exact answers. If we want exact answers, we need to leave them in radical form. Now for our guided practice section. We're going to work through some problems together. You do not need to write down these problems, just step through them with me. At each step, I'm going to prompt you the question you should be asking yourself, then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So our first question is, what are we trying to do here? What we're trying to do is solve this quadratic equation by using the quadratic formula. So how do we do that? Well, first we need to get it in standard form by subtracting 14 from both sides, because it needs to equal 0 before we can use the quadratic formula. Now what? Now we identify what a, b, and c equals. What's next? Now we substitute those values into the quadratic formula. Now what? Now we begin simplifying. What's next? We continue simplifying underneath the radical. Now what? Now we take the square root of 81 to get plus or minus 9. Are we finished? No. Now we split out our two possible solutions. Then what? Then we simplify each of our solutions. Are we finished? Yes, we are. Although if we wanted to, we could check our solutions by substituting back into the original equation and making sure they both work. Let's try another one. What do we do first? We need to get it into standard form by adding 8 to both sides. Now what? Now we identify a, b, and c. What's next? Now we substitute those into our quadratic formula. What's our next step? Our next step is to simplify. Then what? Well, we can either leave it like this in radical form, or we can approximate our answer by taking the square root of 273, rounding it, and simplifying. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now, work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem, and work it out in your notebook. Then press play to check. Please pause the video now. Here's the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve a quadratic equation in the form ax squared plus bx plus c equals 0 by using the quadratic formula. We did this by learning the quadratic formula and how to simplify it using the values of a, b, and c. We also learned that there could be no solution when the value inside the square root was negative, and that sometimes we'll get square roots of numbers that aren't perfect squares, so we can use our calculators to get an approximate answer.